Okay, so for number 17, we're going to add or subtract and simplify, right? And there's a big difference between multiplying and dividing, right? Adding and subtracting is not the same thing. So it's done very differently, right? So for part A, well, this should be an easy one. And that's because when you're adding fractions, right, whatever the denominator is, if it's the same denominator, you're just adding the numerators, right? And the same thing is true if you were subtracting. This is plus or minus, right? So yeah, in this problem, the denominator, x minus 4, is the same for both. That is our least common denominator. So all we have to do, is just add the two numerators. And I would say we're done, except I think we can go a little bit further here, right? We have to multiply out the numerator. So this is x times x, which is x squared, plus 2 times x. And then the same thing with the 3, right? That's what the parentheses mean. It means multiply. So 3 times x. And then 3 times negative 12 is negative 36. All right, and we're still not done because 2x plus 3x is 5x. So just combining like terms. And now you might think we're done, except remember, we still have to simplify. Simplify means factor and cancel. There's nothing we can factor out of the denominator. It's just x minus 4. But the numerator, well, what two numbers multiply to negative 36 and add to 5? All right, I hope you got it. So spoiler alert, plus 9 and minus 4. 9 times negative 4 is negative 36, and 9 minus 4 is 5. So you can see what happens. X minus 4 divided by x minus 4 is 1. It's a common factor, so it cancels. And so our answer is just x plus 9 over 1. Right? But dividing by 1 doesn't do anything, so we'll just write x plus 9. Okay, so that's the answer for 17a. Okay, so, you know, still a lot of work, but the fact that the denominators were equal makes this an easy problem. Because if you notice in part B, the denominators are not equal. Right, so what do we do when the denominators are not equal? Well, we have to find the least common denominator, right? You cannot add these fractions at all when the denominators are not equal, right? So again, a very common mistake is to add 7 plus 3 is 10, and then 15 plus 20 is 35, and then x squared plus x cubed is, well, x. So that doesn't work, of course, right? So yeah, you don't add the denominators. You just don't do it, right? So that would be completely wrong. Right. So you have to find the LCD. And the LCD, you find that by factoring all the denominators completely. Factor the denominators. And in this case, right, 15 is just 3 times 5. Right? And 20 is 4 times 5, but 4 is 2 squared times 5, right? Remember, we want them as exponents. So the LCD, right, you just multiply all the factors. Multiply all the factors, and using the largest exponents, right? With the largest exponents, right? If you do the smallest exponents, you're finding the greatest common factor, which, you know how to do, but that's, that was back in chapter 6 when we were factoring, right? So the least common denominator is going to be 2 squared times 3 times 5 times x cubed, y cubed, because again, we have a choice between a 2 and a 3. We want the largest exponent. 3 is bigger than 2, so we're picking the 3 here, right? So 4 times 3 is 12. 12 times 5 is 60 times x cubed. So that is our least common denominator. Okay, step 2 is we're going back to the original problem here. So let me just copy that down. Okay. And what we need to do is get each of these two denominators, they have to match this. They have to become the least common denominator, right? And you can see they're not at the moment, but we can fix that by multiplying by any missing factors, right? And we're going to do this for both of these. Okay, so what are the missing factors here? Well, right, we're looking for 60x cubed. What number times 15 is 60? 60 divided by 15 is 4. So if I multiply 15 times 4, I get 60. And I only have x squared. I need x cubed. But x squared times x is x cubed. So I'm going to multiply the denominator by 4x. That means I have to multiply the numerator by 4x. Why? Well, I can multiply by 1 and not affect the outcome, right? For the second fraction, I have 20, but I need 60. So 20 times 3 is 60. And I need x cubed, but I already have x cubed, so I don't need any more x's. So there, I just multiply by 3 over 3. I went a little too far there, right? So by doing that, the new numerator is going to be 28 times x divided by 60x cubed plus, right, 3 times 3 is 9, so 9 over 60x cubed. So the whole point of that, right, the whole point for step 2 is to rewrite each fraction so that they have the same denominator. Rewrite each fraction, right, with the LCD. And so we did that, right? Both of the denominators here now are the LCD, 60x cubed. Okay, so that's step 2. Step 3 should be obvious, right? Now that we have the same denominator, we do the same thing as we did in the previous problem. If the denominators are the same, we're just going to add the numerators, right? So add, or if this is a minus sign here, you would subtract. So in other problems, we might have to subtract. But add or subtract the numerators. Okay, so this is my step 3 here, right? We keep the denominator 60x cubed, and we just add the numerators 28x plus 9. And then step 4 is to simplify. Simplify just means, right, the usual factor and cancel. So can we factor the numerator? Well, let's see, 28 is 4 times 7, right? 9 is 3 times 3. They have nothing in common, right? So we can factor, but there's nothing we can factor out of the 28 and the 9. So essentially the numerator is prime. And we could factor the denominator, but there's no point in that, right? This has to be our answer. Right, so in this case, there was nothing to simplify, but just keep in mind that in other problems, there could be. Right, there was in this problem where we had to factor out the x minus 4. Right, but here, this is as far as we can go. All right, let's move on to part C. Okay, we have x minus 32 over x squared minus x minus 12 plus x over x minus 4. And again, the directions just say add and simplify. Right, add and simplify. But we don't have the same denominator. These are not equal. So we have to find the LCD. So what are the two denominators? The first denominator is x squared minus x minus 12. And if you factor that, you just get x minus 4 times x plus 3. The second denominator is x minus 4, which is prime. It's just x minus 4. There's nothing to factor there, right? So the LCD has to include the x minus 4, and it also has to include the x plus 3. Don't get confused with greatest common factor, which is just the x minus 4, because that's the only common factor. Right? We want the LCD. We have to include both the x minus 4 and the x plus 3 as factors. Okay, so that's step 1. Step 2, we're going to rewrite each fraction. So x minus 32 over x minus 4 times x plus 3. That's the factored version. But you'll notice that that's already the LCD, so we don't have to do anything with that. However, in the second fraction, the x over x minus 4, you'll notice that that is not the least common denominator. Right? What are we missing? We're missing the factor of x plus 3. So I have to multiply the denominator by x plus 3 so that it matches the LCD. Right? But if I multiply the denominator by x plus 3, I have to do the same thing in the numerator, so that I'm just multiplying by 1. Right? So the first fraction, I think we can leave that alone. It's just x minus 2 over x minus 4, x plus 3. The second fraction will be x times x plus 3 over x minus 4 times x plus 3. Okay. So, mission accomplished. We have both denominators. These are both identical. They are equal. Okay, so now we just add the numerators, right? So that's step 3. Right. This was step 2, by the way, getting the common denominator, right? Step 1 is finding the LCD, right? So now that we have the same denominator, we'll just write down the denominator, x minus 4 times x plus 3. That's a plus sign. I don't know why that looks like an x. And then the numerator, we have x minus 32 plus x times x plus 3. And why don't we just multiply that out, right? X times x is x squared, plus x times 3 is 3 times x. So I'm already starting the process of simplifying here. Right? So now, let's put the x squared in front. And we have 1x plus 3x is 4x, and then the negative 32. So I think that's everything in the numerator. The denominator, we're going to leave that alone. If you're tempted to multiply this out, then you're doing the wrong thing here. Right? You don't want to multiply it out because, remember, we want to simplify. Simplify means factor and cancel. So the denominator is already factored. We still have to factor the numerator. And that's just another trinomial. What two numbers multiply to negative 32, right, and add to positive 4? All right, so it's not 1 or negative 1 and 32. It's not negative 2 and 16. It's not divisible by 3. So I think it's going to be positive 8 and negative 4, right? 8 times negative 4 is negative 32. 8 minus 4 is 4. Okay, so that's now everything is factored completely. Step 4, simplify, right? So factor and cancel. We did the factoring. Now we just cancel the x minus 4s, leaving us with x plus 8 in the numerator and x plus 3 in the denominator. Right. And if you leave parentheses around it, that's probably okay with me. Just to emphasize that, right, these are factors, and they're the only factors in the numerator and denominator, right? So that's it. That's our answer. Remember, you do not cancel the x's. That would be a mistake. This is not 8 over 3. Right? It's x plus 8 over x plus 3. Right, so that's number 17C. And I guess I'll do D because that's a subtraction, and we haven't done a subtraction yet. Okay, so we want to subtract and simplify 3 times x plus 2 over x squared plus 4x plus 3 minus 2 times x minus 3 over x squared minus 1. Okay. So remember, first we look at the denominators. We see they're not the same, so we have to find the LCD. Let me do that over here. So the two denominators are x squared plus 4x plus 3. When you factor that, you just get x plus 1 times x plus 3. And the other denominator is x squared minus 1, and that's just a squared minus b squared, right? So x minus 1 times x plus 1. So our LCD has to include all three of these factors, x minus 1, x plus 1, and x plus 3. Right? You don't have to write x plus 1 squared, right? You don't have to multiply x plus 1 times x plus 1. You can, but you don't need to make the exponents bigger than necessary, right? Remember, we're using the largest exponents for all the factors. All the exponents are just 1s here, in these invisible 1s. So the biggest exponent of x plus 1 is not 2, right? It's just 1. So when all the exponents are 1s, you can just use 1s as your exponent. Right? So that's our LCD. Okay, so before I do the next step, I'm just going to rewrite this with the denominators factored now. Oh, I should have left a little bit more space here. X minus 1, x plus 1. Okay, good enough. So, yep, remember we are subtracting these. So I'll put a little minus sign here. All right, so this is what we have so far. All I did was just factor the denominators here. Right? So what do we need now? We need to get both fractions to have the same denominator. And that same denominator is this, the LCD. So in the first fraction, we have x plus 1, right? We have x plus 3. What we don't have is x minus 1. So I need to multiply the denominator by x minus 1. And if I do that, I have to multiply the numerator by x minus 1 as well. Okay, let me do that over again. I didn't need to do that in a different color. I mean, that might help. But again, you're just multiplying by x minus 1 over x minus 1. Right. And so for the second fraction, we have x minus 1. We have x plus 1. And you can see what we're missing is the x plus 3 here. So I have to multiply the denominator by x plus 3. If I do that, I have to multiply the numerator by x plus 3 also. And so I think that's good enough. Now the denominators are the same, right? These are identical. Oh, they don't look the same, right? Because maybe they're just in the wrong order here, right? But remember, order doesn't matter. Or if it really bothers you, just rewrite it in the same order, right? You have the x minus 1, you have the x plus 3, and you have the x plus 1, right? So the order doesn't matter. But if it bothers you, let's just rewrite the second fraction just in the same order, right? So I'll put the x plus 1 first, then the x plus 3, then the x minus 1. Right? The point is it's the same denominator, so in the next step, we'll just write that denominator. Right. Be careful you don't cancel the x plus 3's. You can do that, but if you do that, you're essentially just going backwards. Right? Right? If you cancel the x minus 1's, you're going back to the original problem, and you won't be able to add or subtract anything. Okay, so yeah, don't cancel anything yet. That comes much later. Right? So now what? We have 3 times x plus 2 times x minus 1 minus 2 times x minus 3 times x plus 3. And we still have to simplify, right? Remember, we're not canceling anything yet. What we need to do is essentially multiply all this out here. And if we FOIL this, I should maybe do that in a different color, right? This is going to be x squared plus x plus x minus 2. So if we multiply that times 3, we're going to get 3x squared plus 3x minus 6. All right, over here, x minus 3 times x plus 3, that's just x squared minus 9. And when you multiply by 2, you're going to get 2x squared minus 18. But be careful, you're subtracting the whole thing here, right? And I'm just going to copy down the denominator. We'll take care of that later. Right, so the numerator is still 3x squared plus 3x minus 6 minus 2x squared, but minus a negative 18. Right, so that's plus 18. Don't forget to distribute the negative. All right, so now we have some like terms here, right? 3x squared minus 2x squared is 1x squared. What else? 3x, that's it, just 3x. There's no other x terms, so plus 3x. And then negative 6 plus 18 is positive 12. Okay. And then here's our denominator. Yeah, you don't want to multiply that out because remember, now when we factor the numerator, we might be able to cancel one of the factors in the denominator. So, right, so let's see, what two numbers multiply to 12 and add to 3? Is it obvious? Right, so 1 times 12 is 12. 1 plus 12 is 13, but 13 does not equal 3. We could try 2 times 6, right? 2 plus 6 is 8. That's not equal to 3. And what else can we do? 3 times 4 is 12. But 3 plus 4 is 7, and 7 is definitely not 3. And at this point, we're just going backwards, right? 4 times 3, 3 times 4, same thing. So we tried all these possibilities, and nothing works. None of them add up to 3. So that tells me that we can't factor it, right? The numerator here is prime, right? So that means we're done, right? We cannot factor the numerator, and so we cannot cancel anything here. So we're done, right? So that's our answer for 17D. Okay, moving on to number 18. Still dealing with fractions, but now we want to solve equations that have fractions, right? These are sometimes called rational equations. Here, it doesn't specify, it just says solve the following equations, but these are technically rational equations because they contain fractions. All right, part A, pretty routine. This one should be easy simply because this is a fraction and this is a fraction. When both sides are fractions, you can cross multiply. Right. Now, this won't work, for example, in part C, because in part C, this left side is not a fraction. It's two fractions, right? You're subtracting two fractions. And the same thing for part D here. This left side consists of two fractions that you have to add, right? But in parts A and B, both sides are fractions, right? So when that happens, you can just cross multiply. What that means is I can multiply 5 times u, and that's the left side, and I can multiply 2 times u plus 6. But be careful, you're multiplying 2 times the whole thing, u plus 6. Right? So you need parentheses. And, right, that just gets rid of the fractions. I think you can take it from here. Right? Just distribute the 2. And let's subtract the 2u from both sides. If 3u is equal to 12, when you divide by 3, right, 12 divided by 3 is 4, so u has to be 4. Right? So some of them are just that simple. Now there's one detail that you do have to be careful going forward here. Notice that in the original the original problem, we had the u plus 6 in the denominator. So if u plus 6 equals 0, that would be bad, right? Because we'd be dividing by 0. So u equals negative 6 is a restricted value. It's not allowed. So if that were the answer, you would have to cross it out. But 4 is not negative 6. 4 is not the restricted value. So u equals 4 is correct. And in fact, you can go back and plug that in to check. Oh, let's do that because I'm probably not going to do that in any of the other problems. If u is 4, we get 4 over 4 plus 6 equals 2 over 5. Is that correct? Well, okay. 4 is just 4. 4 plus 6 is 10. Oops, sorry, 10. Does 10 equal 4 over 10, is that equal to 2 over 5? Of course, right? I mean, they don't look like it, but remember, 4 over 10 is not in lowest terms. So if you factor out the 2 here, right, and we can cancel the 2's, we get 2 over 5 equals 2 over 5. And now I think it's obvious that these are equal. So that means u equals 4 is correct, and we checked it. Okay, so part B is done really the same way. So I think I'm going to skip part B. Oh, you know what? Let's not. It's a little bit harder, but not much. The point is, you can still cross multiply, right? 5a minus 2 over a plus 3 is equal to 5a over a plus 1. Right, so again, we can cross multiply. So if we multiply 5a minus 2 times a plus 1, that has to equal 5a times a plus 3. So you can see why this is a little bit trickier. We have to FOIL the left side here. So that's going to be 5a squared plus 5a minus 2a is 3a, and then negative 2 times 1 is negative 2. On the right side, you just have to distribute, right? This is 5a squared plus 15a. And while this looks like a quadratic equation, if I subtract the 5a squared from both sides, you end up with 0 on both sides, right? So really, we just have 3a, that's an a. Try that again. 3a minus 2 equals 15a. So no a squared anymore. This is just a linear equation. And I would subtract the 3a from both sides, leaving you with negative 2 on the left and 12a on the right. So if that bothers you, just switch sides. We have 12a is equal to negative 2. And then just divide by 12. So negative 2 divided by 12 is negative 1/6. So a has to equal negative 1 over 6. And that was not a restricted value. The restricted values were negative 3 and negative 1. So I think that does it for part B, negative 1/6. I'll leave it to you to check. Okay, 18c, we want to solve the equation 3 over x minus 2 over 2x minus 1 equals 4x plus 1 over 2x squared minus x. Right, this one's a little bit more difficult simply because, as I mentioned earlier, this is not a fraction, so cross-multiplying is out here. That's not going to work. Okay, so here are your two options. One option is to, well, subtract these two fractions. When you subtract the two fractions, you'll get a single fraction. Then you can cross-multiply. Right? I don't think I've ever done it that way, so I'm not going to start now. Right? The usual way to do this is, again, find the LCD. So that means we have to factor all the denominators. X is just x. There's nothing to factor there. And 2x minus 1, that's prime, so nothing to factor there. It's on the right side, we can factor out an x, right? 2x squared minus x factors as x times 2x minus 1. So the LCD is just x times 2x minus 1. Okay. So the next step is to multiply both sides by the LCD. by doing that, we are going to get rid of the fractions here, right? So I'm just going to copy this down, and then I'll multiply both sides by the LCD. Okay, so yep, we're going to multiply the left side by the LCD. The LCD, again, is x times 2x minus 1. Squeeze that in there. And then do the same thing on the, on the right side. Now, remember, we're not doing top and bottom here. We're just doing left and right. So to emphasize that, I'm going to put this over 1, right? Because if you multiply numerator and denominator, you're not making it any easier. In fact, you're making it worse, right? So the goal is to get rid of the denominators in this case, not to make them equal. Okay. So on the left side, we have to distribute this. This is going to be 3 times x times 2x minus 1 divided by 1 times x. That's just x, right? Minus. Now we have 2, right? This 2 times x times 2x minus 1 over 2x minus 1 times 1, right? And on the right side, we have what? We have 4x plus 1 times x times 2x minus 1 all over 1 times x times 2x minus 1. Okay, so yeah, quite a mess at this point. Oops, sorry, I didn't mean to do that. However, we can clean this up very quickly here. The whole idea to multiplying by the LCD is to cancel the denominators, right? So now we just want to simplify. Everything should be factored already, so it's really just cancel. What can we cancel in the first fraction? We have x divided by x. They cancel. What about the second fraction? We have 2x minus 1 over 2x minus 1. We can cancel those, right? And on the right side, we have x divided by x. They cancel. And we have 2x minus 1 over 2x minus 1. Those cancel. So look at the denominators. There's nothing left, right? We canceled all the denominators. That was our goal, right? Now we have what's left over is 3 times 2x minus 1 minus 2x equals 4x plus 1. No denominators, right? Oh, okay, I shouldn't say that. Of course there's a denominator. There's always a denominator, right? It's just 1, right? So what's left over after we canceled are these invisible 1s. But who cares, right? It's just 1. Right? The point is, at this stage, you should be able to solve this very easily. In fact, do that now, if you haven't already done it. So if we multiply this out, we're going to get 6x minus 3 minus 2x equals 4x plus 1. So 6x minus 2x is 4x minus 3 equals 4x plus 1. All right, so I can subtract the 4x from both sides. And when I do that, on the left side I have 0 minus 3, and on the right I have 0 plus 1. So I get negative 3 equals 1. But wait a minute, negative 3 is not equal to 1. That's false. That's wrong, right? So what does that mean? It means we didn't get anything, right? Be careful. The answers are not negative 3 and 1, right? We didn't get x equals negative 3. See, we canceled all the x's, right? 4x minus 4x is 0. They're gone. So we didn't get x equals negative 3, right? We didn't get x equals 1. We got negative 3 equals 1, which is just wrong. It's not an equation. It's false, right? So that tells me this equation has no solution. Right? That is always a possibility. Right? Just because you can write down an equation doesn't mean you're going to get a solution. And this is the case. So, yep, so this equation has no solution. There's nothing to check because there's no answer here. Right. Right. And again, it's a complicated equation, but it doesn't matter if it's complicated or not. It has no answer. It has no solution. Right. You might want to go back and check that we did everything correctly here. I think we did. I don't think I did anything wrong. If I did, then then that could lead to mistakes. But I think this is correct. I think there's no solution, right? And in fact, that's what it says in the answer key, so I think that's right. By the way, if you're looking for another equation with no solution, there's an easy one you can write. X plus 1 equals x. Right? If you try to solve this equation, you'll see very quickly you get no solution. Because any number that you add to x, if you add 1 to any number, rather, you're not going to get back x. Right? 3 plus 1 does not equal 3. Right? 12 plus 1 does not equal 12. Right? So x plus 1 will never be equal to x. All right. Okay, 18d, we want to solve this equation. 2x over x minus 3 plus 6 over x minus 3. Oh, I'm sorry. The second denominator should be x plus 3. 6 over x plus 3 equals negative 28 over x squared minus 9. Okay, so it's done the exact same way as the previous problem, right? So I'm just going to copy it down. And the idea is to find the least common denominator, which I hope is obvious. Especially if I factor the x squared minus 9, it's just x minus 3 times x plus 3. So that has to be the LCD, right? X minus 3 times x plus 3. Or x plus 3 times x, right? The order doesn't matter. If you switch the order, same thing, right? Okay, so now we just multiply both sides by the LCD. So we're going to multiply both sides by x minus 3 times x plus 3. So that's the left side. On the right side, I'm going to have to squeeze that in here, just enough space. So remember, we're only multiplying the numerators by the LCD, not the denominators. We still have to distribute on the left here, so that gives us 2x times x minus 3 times x plus 3, right, all over x minus 3. You can already see what's going to cancel here, right? Let's not get ahead of ourselves. We'll do that later, right? Plus, and then 6, right? 6 times x minus 3 times x plus 3, all over x plus 3. And that's going to equal negative 28 times x minus 3 times x plus 3 over x minus 3 times x plus 3. In fact, we didn't have to do that, right? You can just cancel right away here. But I want to go step by step, right? So having done that, you get a giant mess, but it cleans up pretty easily. Let's cancel the x minus 3's. Let's cancel the x plus 3's. And on the right side, the x minus 3's cancel, the x plus 3's cancel. The only thing left is the negative 28, right? So on the left side, the only thing on the right is negative 28. Right? I'm getting that confused. All right, so the left side is 2x times x plus 3 plus 6 times x minus 3 equals negative 28. So you can take it from here. I think you can solve this. Let's just multiply everything out here. 2x squared plus 6x plus another 6x minus 18, right? 6 times negative 3, negative 18. So let's combine like terms. 6x plus 6x is 12x. And since this is a quadratic equation, why don't I add the 28 to both sides? So we still have 2x squared plus 12x. Negative 18 plus 28 is positive 10. And now the right side is 0, right? So this should look familiar. This is a standard quadratic equation, standard form. right? If you want to use the quadratic formula, go right ahead. If you want to complete the square, that's probably not the best way, but that would work. Well, here's how I'm going to do it. Notice that these are all even numbers. A, B, and C are even numbers, so why don't we just factor out the 2 first? Right? Because we can divide both sides by 2. 0 divided by 2 is still 0. So I think I've made it easier now because A is 1, and I know I can factor this. There's only one possibility. There's only one thing that works here. 5 times 1 is 5, and 5 plus 1 is 6. So there's no choice. It has to be 5 and 1. And when you set them equal to 0, you get x equals -1 and x equals -5. So those have to be the solutions, right? -1 and -5. So that's it. Now, I didn't check. You should probably check. For one thing, you should make sure that they're not the restricted values, right? The restricted values here are -3 and 3. Right? But we didn't get those as our answers, so that's good. So yeah, if one of the answers, let's say another answer was 3, we would have to cross that out because it's a restricted value. But that didn't happen here, so yep. Plug those into the original equation, and you'll see that it works. It's not easy, but it does work. All right, so that's number 18. All right, I think I might squeeze this one in here. This is number 19, right? And this is a word problem. It's an application. So it says someone who weighs 143 pounds on Earth would weigh 54 pounds on Mars, right? Because Mars is a smaller planet, has a lower gravitational field, and you would weigh less, right? Just like the astronauts on the moon, right? They were bouncing around, if you've seen footage. They simply weigh less on smaller objects, smaller planets or moons. If the Mars rover Curiosity weighs 1,982 pounds on Earth, calculate its weight on Mars and round to the nearest pound. So this is a very old question, right? The Mars rover Curiosity, it must have been at least a decade ago. But anyways, it's neither here nor there. So what do we know? We know that anyone that weighs 143 pounds on Earth, right, would weigh 54 pounds on Mars. Well, the Mars rover, the Curiosity, weighs 1,982 pounds on Earth, and we want to know how much does it weigh on Mars. So that's the unknown, that's x. So it weighs x pounds on Mars. So these have to be equal, right? These have to be essentially proportional. So you're just solving what I think is a very simple proportion, right? And you can just cross multiply, right? 143 times x is equal to 54 times 1,982, and I will confess I cannot do that in my head, so I'm going to just get out a calculator, and 54 times, I don't know why this does that when I don't want it to. All right, so 143 times x is equal to 54 times 1,982, which is 107,028. So just divide by 143. And again, I cannot do that in my head, so just use a calculator. And I come up with 748.4475244 I think I missed a 5 here. 447552447. Anyways, it doesn't matter because the directions specifically say to round to the nearest pound, right? So the 4s here, well, this 4 just rounds down. So 748 pounds. Okay. So that's the answer to the question. That's number 19.